Welcome back. In this section, we're going to carry on with calculus. We're going to do some more examples. The only way to talk through these and to actually get involved with them is to do the examples. There's no other way. We can talk about it, but if we don't practice calculus, that's it. We're not going to get it under our belts at all. So let us say that we have an f of x. Let's say another example here. Another example here is f of x equal to 3x to the power 5 minus 1 over x squared plus cube root of x squared and minus 5 just for good measure. And they ask for f prime of x, or something, the derivative, or the they want the slope of the tangent at a point. We know we're going to have the derivative. Well, it's very easy for the first one because it's 3 times 5 times x to the 5 minus 1. But what do we do with these others over here? What happens there now? Well, what we're going to do is we are going to say, let us introduce another rule. I am going to rewrite f of x equal to 3x to the power of 5. We put them into x to the minus 2. Right? That's what we've done. We put them all in a long line. We don't have any denominators, and we certainly don't have any surds. We change it to a normal exponent, where the normal exponent is plus x to the power of 2 over 3 minus 5. Now we can use our rules for f prime of x, can't we? We can go and we can say f prime of x is going to be. Now we bring down the n and follow the rules. Look, 3 times 5 to the power of x, 5 minus 1. Minus 1, that's this one, times minus 2, right? Times x to the power of minus 2 minus 1, correct. Plus, bring it down 2/3 times, there's a 1 in front, I just didn't write it there, obviously. X to the 2/3 minus 1 minus 0, because we know the derivative of that is a 0. Derivative of a constant is a 0. That gives us 15x to the 4. Minus 1 times is plus 2, x to the minus 3, plus 2/3 x to the 2/3 minus 1 is minus 1/3, which we then x to the 4th plus 2 over x cubed plus 2 over 3x to the 1/3, or you could write that as 2 over 3 times cube root of x. Right. That and that are the same thing. Okay? We can write it in that fashion should we so choose. So that is how we're going to do ones like that. The step one is you put them all in a long line, change everything to an exponent. Even if it's negative, you don't have it underneath, because we're not going to use what we do in advanced maths or first year maths, is we use quotient rules and things like that. We're not going to do that here. So we just put them to the top. All right. Let us move along. And always write it like that. Yep, so that's that one. Oh, just have a look at this. For those of you who are physics, this is another example. If you've had a look, you will see there's a formula. S is equal to ut plus a half at squared. S is displacement. This is the formula which is the same as delta x is equal to v initial times time plus a half at. You can see displacement, initial velocity, acceleration, and time. Now I am going to differentiate with respect to time. Differentiate with respect to time, which means I'm going to say d by dt of s, okay, which gives me ds by dt. Okay. In other words, the derivative of that so instead of the x, it's t now. So it becomes 1 times u times t to the 1 minus 1, doesn't it? Plus a half times 2 times t to the 2 minus 1. Right? All I'm doing is I'm just differentiating. Instead of an x, I'm using a t, which is going to be equal to u times t to the 0, which is 1. Plus a half times 2 is 1 times t. And my a is in the middle, and my a is over there. Sorry, I forgot him. Okay, let me just get that guy a little sort of tidier than that, because a is in fact a t to the 2 minus 1, like that. So I end up with that. But what is ds by dt? It is delta s over delta t, which is the same as delta x over delta t, which is equal to velocity, meters per second. This is obviously just for the physics guys, but you can see if I differentiate the displacement function, I get the velocity function. Now if I do it again, I say dv by dt, okay, is going to be equal to, u is a constant, so it becomes 0. A, t to the 1 minus 1 is 0, so that becomes 1. So I get dv by dt is equal to a. Well, yes, it is, because that is delta v over delta t, is the acceleration. I think this is making sense. Please have a look here. I'm going to introduce a term. This could also be the second derivative, d2s by dt squared. This is the second derivative. We're going to get to those. You can do the third. You just keep going, basically. That's all you're going to do. Now, having had a look at that one, okay, we've now had a look at a very sort of famous physics one. Let's typically problems, but let's do a recap section quickly. All right. Just remember something. A straight line y is equal to mx plus c. Right? And dy delta x, etc., etc. We know all of that. Then we said if two lines are parallel, then their gradient is equal. If that slope is 1 in 5 and this is 1 in 5, the gradient and the slope must be the same to be parallel. Then we say if two lines intersect orthogonally. What does that mean? Or if they are orthogonal. What does that term mean? It means that they are at 90 degrees. It means at 90 degrees. So if they cross at 90 degrees, we say thus, we say if they cross at 90 degrees, then this is line A and that's B. M of A times M of B must be minus 1. That's the product of the gradients. Product of the gradients must be equal to minus 1. Let's just finish that off. Okay. Now, What we're going to be asked is we're going to do some examples using this. We're going to do some examples using this. They're going to ask us gradients of normals, tangents. Let's look at how we're asked. Here's an example. Here's an example. Find the equation of the normal and the tangent to the curve f of x equal to minus 2 over x squared. Okay, at x equals minus 1. Here they've told us that. So the first thing, let's find point of contact. Step 1 is find point of contact. Because we can't draw that curve, right? Let's say we're not sure what it's going to look like. Okay, I haven't done physics, but in physics we see that curve. Okay, it's an inverse square, isn't it? All right, it's one of the fundamental curves we use. But let's say we haven't seen it, so we can't draw it. So find the point of contact. This is the same as y is equal to minus 2 over x squared. And we are given one x value, x, y, we are given that it is minus 1 and y is what? So y is minus 2 over minus 1 squared, which is minus 2. Therefore, the point of contact, this is where the tangent and the normal touch the curve, is going to be minus 1 and minus 2. I think everybody should be happy with that. Okay. Now, so the point of contact is the first thing. The second thing is find f prime of x. In other words, the first derivative. Okay, we're just going to use the word derivative for the moment until we get to other problems where we're going to use the second derivative. How do I do that? I say f of x is going to be minus 2 over x squared. The rule says to me I change that to minus 2 times x to the minus 2. Then I can follow my standard rules and I can say, okie dokes, you are minus 2 times minus 2 times x to the minus 2 minus 1, which is going to be 4x to the minus 3, which is 4 over x cubed. And there we go. Now, that is the, let's just recap. What have we worked out? That is the slope of the tangent at any point. We have said that the point is x equals, and let me just check, minus 1. Therefore, tangent, now let's work it out. We say the tangent, first of all, is always y equals mx plus c. Let's work out m of the tangent is equal to 4 over x cubed at x equals minus 1 is going to be 4 over minus 1 cubed. That's going to be minus, so it's going to be minus 4, isn't it? Minus 4. Therefore, the tangent, we're still working on the tangent, minus 4x plus c. Now, subs in the contact point. That's what we do. That's the recipe. Says do this every time. Okay, and we're going to do these backwards as well. They'll give us the normal, then they'll tell us this, then once you got the recipe forwards, going backwards is just basically turn it around. So we subs the contact point, and the contact point is, let me just refresh, minus 1 minus 2. Therefore we say minus 2 must be equal to minus 4 times minus 1 plus c. that is going to be 4 plus c. Therefore, c is minus 6. And then we have that our tangent, therefore the tangent graph, equation, that's what they're going to ask, the equation of the tangent. The equation of the tangent is y is equal to, and we know it's minus 4x minus 6. Now I say right. Next, we say cool. Another page. Let's go back and make sure we're on black. Yes, I am. Then I write here normal. And I always start off with y equals mx plus c for the normal now. Remember previously I did it in a different color? Y is equal to mx plus c. It's a straight line. Because I've just worked out the tangent, now I'm working on the normal. And they are orthogonal. Orthogonal means 90 degrees, which means m of the tangent times m of the normal must be minus 1. Do I know m of the tangent? Yes, it's minus 4 times m of the normal must be minus 1. Therefore, m of the normal must be equal to minus 1 minus 4, which is a quarter, which is straightforward. So I put that back in, therefore I say y is going to be equal to 1/4 x plus c. And wash, rinse, repeat, do the same in. Now, substitute contact point into the equation. And how do I do that? My contact point is, just let's recap it, minus 1 minus 2. So minus 2 must be equal to a quarter of minus 1 plus c. This is minus a quarter. Okay. Therefore, what am I going to do? I'm going to say it's plus c. Therefore, minus 2 plus a quarter must be equal to c. C turns out to be equal to, c in this case turns out to be minus 7 over 4. My equation is y is equal to 1/4 x minus 7 over 4. There you have it. There you have it. Not too shabby, is it? That's the standard way of doing it. Now, for those of you who would like a bit more of a challenge, this one was sent to me by somebody. Okay, they asked me how would I go about that, and they've said that we have a curve over here. All right, I'm going to just draw this. Bear with me, you can draw it with me. And they've given me a curve over here like so. And then they put a point in here. All right, coming from there like that. And my curve is not very cool. It's supposed to be a parabola. Okay, I'm just going to try and draw it again. Yes, because I want it like that. They've put in a point and they said that's A, that's B, and then they put another line down here. I'm just changing the color. Okay, and that's C. And they said that this f of x over here, this f of x over here was equal to x squared over 9k. They introduced a whole load of stuff. They said this distance over here, the distance was 4.5 times kp. We have no idea what k and p are. And then they said AB is orthogonal, which means AB is orthogonal to BC. AB orthogonal to BC. So that's 90 degrees. And BC intercepts at one point only. Thus BC is a tangent. And because it's orthogonal, AB is a normal. Unfortunately, in many of these, we have to unpack the English. or the mathematiques, whatever it is. We have to unpack that. Keywords, it touches at one point, which means it's a tangent. Orthogonal means it's at 90 degrees. Okay? Therefore, that's what we're going to be given. We have to unpack that into a drawing. Rule number one, you've got to use a drawing when it's given. That's why they give it to you. Okay, so it's 4.5 times kp. Now, then they say, find the equation of the tangent and the normal. Find the equation of the tangent and normal. We've got no numbers. This is very much like university or A-level kind of maths. They're not going to give you numbers. All right? It is a more advanced one. I hope you've taken that down. You can always just rewind and go back and get the drawing. Stay with me on the drawing, because what I want to do is I'm just going to go back to my drawing again and put in what I know. I'm going to put in over here, in blue, I'm going to put in that point coordinates is 4.5 kp. I do not know that at all. K times p. It's not k subscript p. I don't know that. So therefore, well, my recipe says, step one, find the point of contact. Okay. Remember we said find point of contact if we can. Let's find the point of contact. Okay. Well, let's say we've got that f of x is equal to x squared over 9k. All right? And therefore, what is f of 4.5 kp? Well, wherever I've got an x, 4.5 times k times p over 9k. All right? Now, we go ahead and we work that out. I'm going to just do this on the side, 4.5 x squared, whoops, it's my bad, 4.5 x squared equals 81 over 4 times k squared, p squared, divided by 9k. So 81 over 4 divided by 9 is going to be 9 over 4, and that's going to cancel, leaving me with kp squared. Now I go back to my drawing 9 over 4 kp squared, and I can fill it in, because I know now that that value there is 9 over 4 kp squared. It's getting a bit tight. My drawing is a little bit crushed, but it's 9 over 4. You get the principle of this. What is my next step? My next step is, okay, I've worked out point of contact. So my next step is to increase the number of pages here. I've got a point of contact. Now I need to find, they've asked me for a tangent. So tangent, I need to get a derivative. I've got f of x equals x squared over 9k. Therefore, find f prime of x. K is going to be a constant. It's 1 over 9k. That's a number. K doesn't come into it. K is a constant. Times 2 times x to the 2 minus 1, which is 2 over 9k x. 2 over 9k x. That is my tangent. What is this? This is the slope at any point. Have they given us an x? Have they given us an x? Yes, they have. They have said, but x is equal to 4.5k. Therefore, the slope at, that's at point B. The slope at point B is going to be, substitute that in, equal to 2 times 4.5k all over 9k. Okay, is that and that's going to give me is 4.5. Let me see, 4.5 slope 2 times 4.5 kp. Sorry, 4.5 kp. I knew this one was going to be a tricky kp. Okay, at that. So my eventual answer is going to be equal to 2 times that is 9 kp over 9k. My answer is going to be p. Therefore, the slope is p. Whatever p is. Who cares? We're just following the recipe a la Kevin, aren't we? That's what we're doing. So, therefore, we say, therefore, the equation of the tangent is y is equal to mx plus c. I've just worked out it, so it's y is equal to px plus c. And now I subs in my contact point. Remember? Can you see the recipe's the same? I'm just going to substitute in the contact point. And the contact point, I'm going to rewrite it down, is 4.5 kp, and let me just get it right here, 9 over 4 kp squared. Correct? It's just that's all it is. I know, it looks and sounds more difficult than it is. Now I just put that in. So therefore, y, this is x, 9 over 4 kp squared is equal to p times x is 4.5. I'm going to change 4.5. That's going to be 4 is equal to, I just want to get rid of that, it's a mess. That's 4.5 is equal to 8, 9 over 2. So I'm going to change that to 9 over 2 times kp. All I've done is I've just changed the fraction because I'm just keeping them in fractions. So that's that times that plus c. Let's do it. 9 over 4 kp squared is equal to 9 over 2 kp squared plus c. C is therefore going to be equal to 9 over 4 kp squared minus 9 over 2 kp squared, which is going to be equal to minus 9 over 2 kp squared. Okay, 9 over 2 is going to be equal to, that's going to be 18 over 4. Let's just go up here. That's 9 over 4 minus that. That's going to be 9 over 4 kp squared minus 18 over 4 kp squared. That's going to be equal to minus 9 over 4 kp squared. Cool. And we are done. Therefore, we will say that y is equal to p times x, because that was that, minus 9kp squared over 4. Done. And let me just tick that off there. Minus 9kp squared over 4. And pretty much that's where we stand. All that I did there is I used, okay, granted it's a more difficult one. Now let's carry on and say, what is then the normal? I think you get the gist of this. The normal, y equals mx plus c. Normal tangent, therefore m of the tangent times m of the normal equals minus 1. Therefore m of the normal, m of the tangent was p times that equals minus 1. Therefore m of the normal is minus 1 over p. I think you get the gist of this. It continues in the same vein. Therefore we say y, I'm still doing the normal now. Let me just bring it down. Can you see? I'm in the normal column. So y is going to be minus 1 over p times x plus c. What do I do next? I substitute the contact point. All right, which was, just for my reference again, the contact point was 4.5 kp, which I changed to, I think, 9 over 2 kp, and it was 9 over 4 kp squared, I think. Like so. Yes. Just check for kp, 9 over 4 kp squared. Yep, that's like that. So I put that in and I say you are 9 over 4 kp squared is equal to minus 1 over p times 9 over 2 kp, okay, plus c. And you can see here it just starts now becoming algebra. 9 over 4 kp squared is equal to, the p's cancel, and I get minus 9 over 2k plus c. C therefore is going to be equal to 9 over 4 kp squared plus 9 over 2k. And what do? I go and I bang that back into it and I say y is equal to minus 1 over px, which is what it was, plus 9 over 4 kp squared plus 9 over 2k. And we are done. This is then the equation of the normal. Yeah, that was not a simple one. It was not meant to be a simple one. And yeah, that was tough. Just go through it and you'll see the recipe stays the same. The numbers get a bit murky and a bit there, but it's all just the same recipe. Cheers. Thanks for watching. We're going to continue with more examples. Bye for now.